2, 3, go!
Hello everyone, my name is Michael Bagley and I'm happy to help you out with some math and manufacturing. This is paid for from a California Community Colleges grant from the Chancellor's office called Doing What Matters for Advanced Manufacturing. And the concepts I'd like to talk about today are order of operations, sometimes called Pemdas, variables, formulas, units, and solving for an unknown. I have a particularly interesting example about finding the area of a ring that you might see, cutting a ring out in advanced manufacturing, needing to calculate an area. And I want to make sure we know it's from a book called Mathematics for Machine Technology by Peterson and Smith. If we look at this ring, it has what they call a outside radius, or like the radius of the circle if it were whole, of 5.126 inches. And the inner circle has an inside radius of 2.017 inches. The nice thing about manufacturing and application is you'll have a lot of manuals and books and guides with formulas. So you don't have to derive the formula, but the reality is you have to know how to use proper rules of mathematics to get it to work for you. And in this case, order of operations, the formula gives you the area of this ring is pi times the outside, the large R squared, minus pi times the little radius squared. And what do we do first? Do we do subtraction first? Do we multiply pi times the large radius and then square it? What is the most important? How do we do it to get the right answer? So I put a little formula up here, and I wrote it differently than many people see it. P stands for parentheses. That's the most important thing to deal with first. E is exponents. Tackle that next. And this is order of priority. Notice I put M and D kind of on a column. Multiplication and division have the same authority or power. And a lot of times you don't see that if you just write it out horizontally. So what do you do first, multiplication or division? Well, the answer is you do what's on the left. That has priority. It goes left to right with priority if you have a tie. Likewise, addition and subtraction, do the one on the left first. So we have our information, we have our formula. Let's start plugging things in. And I want to talk to you about a mathematical secret I use. When you put in a number, an actual value representing a real thing, like a metal ring, I put parentheses to note I just changed the variable, the letter, into its actual value. I usually put parentheses there. But notice here again, 3.14 is being multiplied by this entire thing. Many people, smart people, will accidentally make a mistake of just multiplying 3.14 times 5.126 and then squaring, and that's wrong. So you follow your order of operations. Notice this. You might say, which one do I do first? This exponent or that exponent? They're both equally powerful. What did I say for a tie? Do the one on the left first. So we do this exponent first. So 5.126 raised to the second power multiplied by itself. And I rewrote everything so you could see it is 26.276. I put too many steps, and my students usually are not mad about that. I wrote all kinds of things. You can get fast and you can take shortcuts, but make sure you start off slow to get good with your order of operations. Then we squared the next. We did the exponent on the right side, got 4.068. Now what do? Do we multiply this one first, or do we multiply these two? Again, the one on the left, right? No pun intended, the one on the left. Multiply it out, multiply this one out, I skipped a step. You're going to subtract these two quantities, and you get square inches for this area of a ring. Pretty cool. Make sure you notice your units. On this one, some of you, and I want to be honest with you, when you're doing math, you're not necessarily paying attention to the units. But when you're doing math in manufacturing and what we call error of tolerance, how precise, precision in these things you want to have, you need to start paying attention to what you're being told, how accurate it needs to be. The next example I'm doing will show you accuracy, and I'll talk a little bit about significant figures. That's another mathematical concept. In this one, you even notice that pi, that irrational constant that's always famous for geometry. This pi, I just took it to 2 decimal places. And you know, if you're not totally concerned for super accurate, this is going to be fine. But you could take pi to as many decimal places as you want if it's that accurate and precise. So let's continue looking at another example. Cutting speed. For different types of machines, lathes, drills, milling cutters, grinding wheels. Again, look at this. We have a beautiful formula set up that you can use, but you have to make sure you're using it properly and effectively. I took this example also from Mathematics for Machine Technology. We have our formula, and sometimes when you look at constants, can you start looking into this formula? Where do you think the 3.14 might be? Yeah, probably from pi. 12, huh? I wonder where the 12 comes from. Well, this formula applies to U.S. customary units. Again, be careful about your units. It's not the metric system, it's U.S. customary units. It turns out cutting speed is often recorded as feet per minute. Well, if you think your diameter is in inches, what do you think happens when you take inches and divide it by 12? Ah, you get feet per minute. So that's giving you a little insight into the formula. But here's the reality. As long as you know how to properly apply math to a formula, you're going to get these answers right, even without knowing how they derived it. So I'm looking at an example. You have a steel shaft, 2.500 inches in diameter. Why would I put those extra zeros out there? Yeah, that means I measured it very precise, and that is important to me. I need to keep those three significant figures past the decimal point. It's turned in a lathe at 184.0 revolutions per minute. Notice that this has only one spot past the decimal, so you got to pay attention. Usually the one with the least accuracy is how you have to constrain your answer. So right now it's only going one decimal place over. The question asked you, can you determine the cutting speed? Get this, to one decimal place. Huh, because this only goes one decimal place. That shows you how accurate you need to be. I plug in all these numbers. Oh my gosh, what do I do first? It's that Pemdas. Well, in this case, you're not going to get yourself in trouble. You're just going to multiply these things one at a time across. I got you the numbers. You divide, once you get the top, I usually divide by the bottom. You end up getting 120.4 feet per minute as your cutting speed for this lathe. Cutting speed is an important factor in manufacturing. If it's going too fast, it can cause some issues. So make sure you know the math behind it. Let's look at these learning outcomes one more time. We talk about order of operations. Can you handle these variables? They mean something in manufacturing. Solving for an unknown, in this case cutting speed. Units. I hope this helps you out a lot. I enjoyed doing this. Let's try to see some more videos in math and manufacturing. This is Michael Bagley. Thank you so much.